Hey, welcome, Programming 11. Hey, look, I'm on the screen, kind of. I don't know if this is at all helpful or useful for me to be on the screen, but I thought it might be fun. So here I am, and I thought we would start today by taking a look at bouncing our character off the obstacles. As it is right now in our PewPew game, obstacles aren't much of an obstacle. I think they just stop our bullets, but we can pass through them like we're some kind of a ghost or something. So I think it'd be more interesting if we had to like bounce off of them in our own way. So we're going to be taking a look at how to make that happen. The question is, well, there's many questions, but one of the first questions is, um, where do we put that code? I think that the code itself is probably a little bit familiar to you. If you've been following along with the other lessons, you have a reasonable idea of what to expect with it, but where do you put it? It's kind of hard to say because there's a couple places. You could put it in the obstacle because the obstacles are, already in the game and that's what you're bouncing off of. You could also put it in the player, and the player seems like a good place to put it because we're already doing a lot of checking. So I am going to choose to put it into the obstacle, and here's why. If I put it into the player, I'd have to be looping through the entire list and looking for, hey, am I touching this obstacle? Am I touching that obstacle? Am I touching this one? Am I touching that one? Well, guess what? It turns out the obstacle is already being processed in a list. So each obstacle could just check against the player, and we don't have to write any new loops because obstacle is already in a loop. What loop do you ask? It's in the game function. This loop I've referred to previously as part of your engine code. This loop is processing all the game objects, including obstacles. So if we put it in the show or act function, then it'll automatically start checking. So this seems like a good place to put it. So I'm going to put this in the obstacle. We don't have a show or act function because this is based on the game object, and so far the show and act functions have been more than sufficient from the game object. Our obstacle didn't need to add any new information, but now we do. So we're going to what's called override the act function, which is nothing fancy. It's just that you just make your own act function in here. And I don't necessarily need what was here before. Like the obstacles don't move, but maybe one day I'd like them to move. So I don't know what that would look like, but we'll put that in. If I want the old act function to still happen and then build on top of it, I can say super.act. So this will call GameObject's act function. This has to happen first, and then I can build extra stuff on top of it. So now I'll add in the code for detecting collisions with the player. So here's how I do that. I'm going to be checking to see if the distance between the centers of the circle are less than the sum of the radii. Do you remember that math? I have a little paint sketch here to know if two circles are touching, you can take the distance between the two circles and compare that to the sum of their radii. Because if you take a look, this part of the line is the radius of the yellow circle, and this part of the line is the radius of the purple circle. And if they're equal or less, then these two circles must be intersecting. But if I was to draw a different circle over here, for example, you'll notice that this one's clearly not intersecting. And if I was to draw a line from here to here, then you would see that it is greater than the sum of the radii. So that's the story. So that's how I check collisions. So go put that in. I know it's kind of an old story, but it doesn't hurt to remind people about that. So I can check to see if the distance between this obstacle, its x and y coordinates, and the player's x and y coordinates, spelling's hard, is less than the sum of the radii. So that's going to be size divided by 2, because size is a diameter, plus my player dot size divided by 2. Just to make sure we're clear, anything that's just x, y, size, that's the obstacle, because we're in the obstacle class right now. But I can refer to the player's x and y and size by putting my player dot size in front of it. Why my player? Well, long time ago, we made a player called my player. It's a global variable, so all the classes can access it. So here's our if statement to say, hey, if we're colliding with the player. So now what do? So we'd like to give the player, like we'd like to move the player. We want to like push the player. So we have to say something like my player dot x equals my player dot x plus some number, right? Plus some kind of offset that will push us in the right direction. Also, I know this does not quite work yet, but just hang on here. My player dot y plus, against some number. we want to make sure we're going in the right direction, and it turns out we can calculate that pretty easily because um, if you'll notice, the direction that I want to bounce off, like if I run into this obstacle, I kind of want to be rejected in the direction of that line. That green line almost acts as an arrow. So if I were to find the, oh, that's a circle. If I was to find sort of this component of that line, that would be my offset of x. So I'd like to add that on. And I don't know, I'm running out of colors here. Oh yeah, just have to choose a different one. Oh, it's brown apparently. Cool. And then this component is Vy. So the idea would be here, if I can calculate the Vy, I could bump it up by that much. And if I calculate the Vx, I could bump it over that much in the x coordinates. These lines are very big, so you're going to get a big boost. I'm going to actually bounce back the length of the green line off this way, which is too much. So we'll have to figure out some math to improve that. But we'll start with that. We'll see if we bounce off, at least in a reasonable direction. So I can do that pretty straightforward. I can just take the difference of the x coordinates. So I can say my player dot x minus x, and I'm going to put that in parentheses just to make sure that that's clear what that is. And my player dot y minus y. So just so you know that this, oops, I spelled player wrong, didn't I? Yeah, platter, player, whatever we are. So that there, what that calculation is really the brown line. We're taking the x coordinate of this and the x coordinate of that, subtracting it, and we get the difference here. So that brown line is actually this calculation here. And the red line was this calculation. So if we have a collision, basically we're going to shove the player in by this amount, which will be the right direction. We'll just check and see if that's true. So let's see. It is the right direction. You can see I've bounced off. Like if you draw a line from the center of the two circles, I do bounce in the right direction. It's just like a little too excessive, like pow pow, oh ow, ooh ow, ooh ow. It's just a little too much. It's actually not just a little bit too much, it's a lot too much. So how do we improve this? Well, um, in the Brick Breaker game, we just kind of divided by a constant number, like divide by 10 or whatever number it was. And that's not bad for Brick Breaker because all of our bricks were the same size. So dividing by a constant number, poof, no problem. Let's see what that looks like. I can go and do that and check it out. I actually, look, I bounce off it pretty convincing. I actually kind of slide off of it. It looks pretty good. That works for the larger ones, but watch if I hit a smaller one. I do bounce off, but I can go through it, and I can kind of demonstrate. I think I can still go through. Yeah, you can see I'm going through smaller ones relatively easily. I can't quite get through the medium-sized ones. I definitely can't get through the big ones, but the smaller ones I can get through. Because dividing by 10, like this number is partially based on the size of the obstacle I'm running into. The difference will be smaller. Let me just bring this up. If this purple circle is a lot smaller, then this line is going to be smaller. And if I divide it by 10, it's going to be even smaller still. So we are going to use the p-vector to sort of solve this problem. I don't want to bounce off at a speed that is dependent on the size of the obstacle. Like this gives us the right direction to bounce off of, but it's just not the right speed. So instead of putting this here, watch what I'm going to do. I'm going to make a p-vector, and I'm going to put this calculation into the p-vector. So I'm actually going to get rid of this here. I'll get rid of the divide by 10. And I'm going to make a p-vector, and I'll call it bounce. And it's going to be a new p-vector. And the x component is going to be this number here. And the y component of my p-vector is going to be this number here. All right. Now, p-vectors are pretty confusing. So if you're like, oh, p-vector, what are you doing? Basically, I'm just putting these calculations in here. Now I have an x and y component, and the p-vectors can automatically scale those numbers to match. So if I want to say, this is the right direction, but I'd like this line to be exactly 5 long, that's what p-vectors can do for you. You could do it with trigonometry as well, but we're going to do it this way. Might be a good exercise to try with trigonometry one day. All right, so I'm gonna say basically instead of adding, oh sorry, I gotta actually set now. So I can do bounce dot set mag, and let's say 5. No matter what the size of these circles are, the obstacles and such, I'm always gonna bounce off at a speed of 5. It'll be in the right direction because I did the math right, but then this will sort of set the velocity. So even small circles I'll bounce off correctly. Now what do I put in here? Well, it's gonna just be bounce dot x and bounce dot y. Okay, so let's see if that works. I'm going to go and run that. And you can see that the medium circles, small circles, I just cannot go through any of them. I think there might be a situation where if they're like together, I might be able to like, if I can find maybe some circles where, uh, yeah, maybe not. I don't know. I think there's a way I can like squeeze yeah, there we go. So like if there's two circles that are right close to each other like that, the p vectors will end up like, because I'm colliding with two, the forces will kind of balance out and I'll end up squeezing through. So there's still that problem, but I don't really consider that a problem. I think of that as like a kind of a fun, like if you're running away from somebody, you can squeeze through these cracks. It's like not super fast, but you know you can do it. If the crack is not very big, you can't squeeze through, so I feel like it's fairly realistic. So there you go. There's the bouncing aspect, and I think this game is starting to get pretty interesting and useful. I can obviously still do the shooting, and I'm running into the target, into the obstacles as well. So they actually are obstacles at this point to bullets and to people. Okay, so that's going to be our lesson for today. I hope that made sense, and I hope you had a good time doing that. And I enjoyed being on camera. I guess I'm not too sure how this turned out, so I might look kind of goofy. Like maybe I'm just staring at my code and go slack faced. I didn't really pay attention. Anyways, have yourselves a great day. I really miss you all, and I can't wait to see you again. In the meantime, just stay tuned to the videos and keep learning the program. Bye bye.